In this video, we want to go on to look at problem number 99, and I hope to do this in a much quicker way than we looked at the previous problem. So, a couple of things to remember here. First of all, displacement is simply the integral from a to b of v of t dt, and that is your change in position. Your position at time b minus your position at time a gives you your change in position. Either positive means you've ended up so many units to the right relative to where you started. Negative means you've ended up to the left of where you started. And total distance traveled, well, the easiest way to think about that is that that's basically going to take any time that you're moving to the left and make it seem as if you're moving all in one direction. All the motion is to the right, and so that all of the changes in position are added together. So actually, the easiest way to represent that in notation is just the absolute value of, it's not the absolute value of the whole integral, it's the integral of the absolute value of the velocity function. And that's not simple. We can't just put the absolute value around the s of b minus s of a. But on the calculator, that's really easy to do. And I'll make sure that we have learned how to do that. Algebraically, we're going to have to find out where the velocity is 0 and break the integral into two parts. So let's take a look at number 99 really quickly. So for 99, we have v of t is equal to t cubed minus 10 t squared plus 27t minus 18, and we're looking at the interval from t equals 1 to t equals 7. Alright, so we set up the function there, x cubed minus 10x squared plus 27x minus 18. Now we need to adjust the window. This time I'm going to go from 0 to 10 by ones. I'm not really sure how high or low that's going to go. Just in case, I'm going to let it go from negative 30 to positive 30, and we can adjust that if we need more or much less by fives. So let's take a look at the graph. Alright, and we want to go from 1 to 7. So 1, 2, 3, 4, 5, 6, 7. Great. I think we should be able to see everything pretty clearly there. Now, what you do want to notice here, again, is that when the velocity curve is below the x-axis, then we're moving to the left. When it's above the x-axis, we're moving to the right. Again, below the x-axis, we're moving to the left again. And then above the x-axis, we are moving to the right. So we start off moving left, move right, move left, move right. And recall that the definite integral will give us our displacement. And for our purposes, it's going to be okay. These questions can be quite involved algebraically and time consuming, so we're going to be able to use the calculator to get a solution to these. So displacement, so let's say displacement is simply the integral from 0 to 7 of v of t dt, and that's going to be your net change in position, how far you end up relative to where you started. Even though we're moving to the left, right, let's see where we end up. Alright, and so I'm going to bring in the calculator again, and I'm simply going to take the integral from, option 7, from 0 to 7, and you're going to see some below, some above, some below, and some above. That means we have a total net change in position of negative 7.583. Again, we could break this integral up. If you had time, you could find those zeros in there, and you could actually, it looks like the zeros are pretty easy to identify. Probably we have t equals 0, t equals 1, t equals 3, and t equals 6. And we could find those algebraically by doing some factoring and working with what we have there. For the sake of time, however, I'm simply going to allow you to use the graphing calculator to be able to find that, the displacement. Again, this one is not a difficult integral for us to do. We definitely might need a calculator at some point to do the calculations. All we're going to do, find the antiderivative, evaluate at the upper limit, minus at the lower limit. For total distance traveled here, you simply want the integral from 0 to 7 of the absolute value of the velocity function. And we'll go to our calculator and see what that looks like. This time we're going to come back, do second, delete, which is insert, go to math, option 1, that's not what we wanted. So I can go back and hit the delete key. Alright, so second, delete, which is insert, go to math, then over to number and option 1, absolute value, and close the parenthesis. This time when we graph, watch what happens. So you can see when we take the absolute value of the function, all of the negative segments flip over the x-axis and become positive. When we take the integral of that from 0 to 7, lower limit 0, upper limit 7, what we're now going to get is all of the areas as if they were positive, and that would give us the total distance traveled, or 30.099. And I'll put a copy of that graph onto the screen there also. So this is really the easiest way to do this, using the calculator to find the displacement. It's just the integral from 0 to 7. The total distance traveled, it's simply the integral of the absolute value of the velocity function from 0 to 7. And so that's going to take care of that. We could do this algebraically, but we'll hold off on that for a second. Alright, so that's problem number 99, and in the next video we'll take a look at problem number 101 in a similar fashion, and we're almost done with this section.